Good morning. Today we're going to be looking at the data structure and array. It's a way of holding lots of an individual type of object in a single cohesive whole. Now, I have a single duck right here, I have another duck right here, another duck right here, and that's great. I have a few variables. Now, if I'm only doing, like, say, 3, 4, 5, 6, it's no big deal to have 3, 4, 5, 6, 10 variables of the same thing. But say, for example, for some bizarre reason, I need to actually talk about lots of things, which we often have to do in computer science, like, say, thousands, hundreds of thousands, millions, billions even. And the way we're going to be doing that, if we know that it's a fixed size amount of items, the way to do that is actually be using a data structure called the array. So if I have a certain number of items, a fixed amount, that I need to actually hold those items and actually work on them and deal with them, I need to make a data structure called an array. And so what we're going to be doing with that is we actually have to deal with an array in Java. And so we have a couple things to do with that. Now up here on my board, I've got a few ducks in a row. I know, bad joke, but that's okay. The ducks in a row would be an array of ducks, because I have 3 ducks right here that I'm going to be working with. And so we're going to be using that as our ducks in a row, or array that we're going to be talking about. Now, to start off with an array of ducks, all we have to do is we just go right here and we say duck array, because there's not a keyword for an array in Java. It's just the magic square bracket symbol. Now, this is the type of thing that I'm actually doing with. So that's the type. It's a duck array. It's not just duck, it's a duck array. And then I give it a variable name, just like normal in Java. And so this will be my ducks equals, and then a new, because we're instantiating a new piece of memory, and then duck. But instead of a constructor, we're going to use the square brackets and say 3. And that builds our array of ducks, sort of. What it actually does is it gives us a box right here, 0, 1, 2, where I have the capability of holding ducks, but by default, it's all filled with null. Yeah, null equals a null pointer exception. We touch that, we burn, we die. Our program crashes and it's no fun. So if we're going to actually resolve that problem, we have to actually instantiate our array so it has values inside that. Now, if we know our contents in advance, we can use an initialization list. AKA, we can go right here and say my ducks instead of a new duck array of size 3. We can simply say like this, and we use these squiggles. And I can say yellow, yellow 2, and magenta. And so what we have right here is I've created a new array of ducks. I've got 3 of them right here, variable yellow 2, and variable magenta, where I can go over here right now, boom, 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 0, 1, and 2, and I have my array of ducks right here. And that immediately creates my array with some pre-existing data. And again, because I have an array, I have a fixed size. It's always going to be this big. And so I can put it right here, so initialize it right that. Or if I don't have them in advance, I can use this right here, making a duck array of size 3. But I have my duck array of size 3, but if I don't know all my things that are going to be putting inside that, instead of using the initialization sequence that I've got right here, what I can do is I can use the access to an array by taking the variable name, my ducks, and then the index that I'm accessing, in this case 0, and then assigning a value to it, in this case yellow. Yellow 1, and then my ducks, sub 1, and I'll use sub to indicate which index I'm talking about, equals yellow 2. And of course my duck sub 3. No, not sub 3. My duck sub 2, the third spot of the array, is going to be magenta. Because I have in my array over here, yellow, yellow, and magenta. So we actually have that array right there. So I can initialize it with initialization sequence, or I can go through and assign each value of my index, 0, 1, and 2, where I'm going to put the value inside that. So we can put our array together like that. Now, once we've got our array of ducks, what we need to do then is we need to actually do stuff with it, because we can refer to each individual duck and look at its state, because each thing inside my array is its own entity. It's its own object. So I have my array of objects, my ducks, but I have duck sub 0, duck sub 1, and duck sub 2. They're each their own object. So duck sub 0 right here, I've got it right here in my duck. Instead of having it sitting it down, I'm going to have it do a headstand, because I can. So flip. And so my duck flips, and now my duck is upside down. This duck, I'm going to take it right here. Instead of facing 0, I'm going to have it face 180. So it's now facing straight down. Okay, and this other duck, my magenta duck, I'll have it turn, and it's going to rotate 45. So it's now facing up and to the right. Okay, and I can have them dance, and so I could randomly change the state of each of these different values. Because when I talk to an array, every time I'm going through this, I can use that. And the way we do that most often is by using an array. The way we talk to each individual spot inside an array is most often by using a for loop, because then we can actually go through and talk to each index and ask each index value, the object stored at that index, to do something specific. And so the way we do that, really not big a deal. So we have my ducks right here. It's a reference to our lovely array of ducks. And I want to use a loop to go ahead and talk to each individual duck inside that array. The way we're going to do that is with a regular for loop. And the way we can do that is just by doing our standard for loop. So I'm going to just go for, and then parens, because of course we always do everything with parens. And then I'm going to start off with int index equals 0. And so, in order to loop over this, I start off with int index is equal to 0. Starting off at the 0th spot, aka the beginning of my array. I'm going to go and I'm going to continue my loop until index is less than my ducks.length, so how big my array is. I'm going to go up to 1 less than that. And my index is going to go up by 1 each time, so plus equals 1. This can also be shortcutted as plus plus. But because I'm also teaching Swift, I want to avoid the plus plus because that feature is not implemented in that language any longer. So I have my loop right here. It's going to go ahead and it's going to talk to my array of ducks, starting at 0, going to 1, and then going to 2. And as I go through that loop, I can actually affect each individual duck stored in my array at that point. So if I have right here my squigs and my ducks, subindex, because at that index right here, this I'm talking to at that point, I'm talking to the array at this spot, aka this duck, or this duck, wherever I am inside my loop. And I can then call any method on my duck at that point by simply using the dot operator. So I'm now referring to the duck at this point. So my duck's subindex is actually talking to an individual duck. So I can call any method. So I can call the dance method on each individual duck just like this. That's going to tell each individual duck to dance. Now, I can also take this out, and instead of referring to the array subindex and then call the method on that, I can extract the individual object out of the array, refer to it as a variable, and then do the same thing. And that will do right over here in blue. So for the temp version of that, the other version we can do is I can take a duck variable, I'll call it temp, and temp is equal to my duck's subindex. So I'm going to extract the duck that's stored at this spot, I'm going to grab that duck, and I'm going to store it into the temp variable. And then I'm going to tell that temporary duck to dance. So in the case of this duck right here, I get 0. I get my duck that was at spot 0. So this is this duck right here. I'm going to take this duck. So this duck right here is duck 0. I'm going to grab this. I'm now talking. This is now temp. I'm going to tell that duck to dance. And then I exit my loop. Index goes up by 1. I then refer to the second duck in my loop at index 1. I grab that duck out of it. I tell it to dance. Or I say duck temp equals my duck subindex, and I tell it to dance. And I repeat that process. So this line right here, my duck subindex.dance, is equivalent to the duck temp equals my duck subindex, and then temp.dance. So I can either extract a duck out of my array, or I can refer to the duck by using the data structure itself, its index, and then use the dot operator to go inside it. Now, this I think is usually the easiest way to handle this. where I talk about the data structure and then its index and then call the dot operator on that. But if I feel more comfortable with looking at something individually, all I have to do to extract my duck or whatever I'm storing inside my data structure out of its spot is refer to the type of variable I'm holding. In this case, my array is an array of ducks. So make a duck variable. I give it a nice name, say temp. I then extract the data from the array by talking about the array itself, its index inside my square brackets, so which extracts that value, the reference to this duck right up here at that index, and I store it in this variable. I then have access to use the dot operator on that temporary variable. It's of type duck, and I can do all the operations on that. And so I can actually extract my data from that. And so that's what we're going to be looking at here in the code and doing some more with this. All right? Sweet.